Welcome. We're about to dive into one of the most wonderfully strange ideas in all of physics. I mean, this is a thought experiment that just might blow your mind.
Just let that sink in for a second. Every single electron, the ones in your body, the ones in the sun, the ones in the most distant galaxy, what if it was all just one single particle?
So yeah, that is the core of what we're digging into today. An idea so out there, it suggests that trillions upon trillions of electrons we see are, well, they're just different appearances of the very same thing. So how in the world could that even be possible? Well, the idea is that this one lonely electron is on this absolutely epic journey, just weaving backward and forward through time, creating what's been called a tremendous knot. And at any given moment, like right now, we're just seeing a slice through that knot. And that slice looks to us like countless individual electrons.
Now, I know this sounds like something straight out of science fiction, but it was actually proposed to solve a very real, very deep puzzle in physics, one that gets to the very heart of what it means to be something in the quantum world. So this big idea came from the mind of the brilliant physicist John Archibald Wheeler way back in 1940. And he was grappling with this fundamental fact about our universe that, most of us just take for granted.
And here's where we get to the mystery. Every electron is a perfect clone of every other electron. And I don't just mean similar. I mean they are absolutely identical. Same mass, same charge. They're completely indistinguishable. So Wheeler's logic was beautifully simple. If you can't tell them apart, well, maybe that's because they are, in fact, the exact same thing.
Okay, so if they are all the same one, how does that actually work? This is where the idea gets truly wild, and it involves time travel and its weird cousin, antimatter.
So here's the crucial piece of the puzzle. Wheeler realized that when this single electron hits a point in time and sort of bounces to start moving backward, something amazing happens. To us, an observer stuck moving forward in time, that electron, moving backward, looks for all the world like its antimatter twin, the positron, moving forward.
Wheeler's student at the time was none other than the legendary Richard Feynman, and he absolutely loved this idea. His analogy for it is just brilliant. Imagine the entire path of this single electron through all of space-time is like one long tangled-up string, a tremendous knot. Now, if we observe the universe at one specific moment, it's like taking a knife and slicing right through that knot. We'd see all these little dots where the string passes through our slice. Those are the electrons, and the dots where the string is looping back from the future, to us, those look like positrons.
It's an incredibly neat, incredibly elegant idea. But like a lot of beautiful ideas in science, it crashed head-on into a very harsh reality. There's a fatal flaw.
And you're probably thinking, okay, if it explains why all electrons are the same so perfectly, what could possibly be wrong with it? Well, it turns out the theory makes one very strong, very testable prediction.
See, if every forward-moving piece of that knot is an electron, and every backward-moving piece is a positron, then for every time the string enters our slice of time, it has to exit too. That means the universe should have an exactly equal number of electrons and positrons. But it doesn't. Not even close. Our universe is overwhelmingly made of matter. Electrons are everywhere. Positrons are incredibly rare.
And yeah, that's the killer. The theory's core requirement, this perfect balance between matter and antimatter, is just completely shot down by what we actually see out there. Even Wheeler knew this was a huge problem, but he thought the idea was just too cool not to talk about.
So if the one electron theory is wrong, then what's the right answer? Why are all electrons identical? Well, modern physics has a different explanation. And honestly, it's profound in its own way.
The answer lies in a theory called Quantum Electrodynamics, or QED for short. And it basically asks us to change how we think about what a particle even is.
In QED, the most fundamental thing in the universe isn't a particle like an electron. Nope, it's the electron field. You can think of it as this invisible substance, I guess, that exists everywhere, throughout all of space-time. The particles aren't the main characters in this story. The fields are.
So what we call an electron is really just a little vibration, a ripple, a tiny packet of energy, a quantum, in this underlying electron field. And the reason all electrons are identical? It's because they're all identical excitations of the exact same fundamental field. It's like how every wave in the ocean is made of the same water. And this brings us to the final nail in the coffin for the one electron idea. It turns out the number of electrons in the universe isn't even fixed.
In certain particle interactions, like when a W- boson decays, a brand new electron can literally be created out of pure energy. This proves that electrons aren't some fixed set of objects, but are just temporary products of that underlying quantum field.
So, okay, the one-electron universe theory is wrong. But that doesn't make it useless. Not at all. In fact, it's a perfect example of something that's incredibly important in science.
Wheeler's idea, as creative and, well, ultimately wrong as it was, it forced physicists to think really hard about these deep questions, about identity and time and antimatter. It was a beautiful, wrong idea that stretched everyone's imagination and helped pave the way for more solid theories like QED. You know, sometimes asking a brilliant question is way more important than having the right answer right away.
And that kind of leaves us with a final thought, doesn't it? Science isn't just a straight line to the truth. It's this winding path, full of these amazing detours. It really makes you wonder, what other grand, beautiful, and maybe totally wrong ideas are out there right now, pushing us toward the next great discovery? Thanks for tuning in.